And I'm live. That is pretty cool. Today is 3rd of November 2025, Monday, and with that, let's just begin. Yes, we will be solving 1600 rated question. Code forces problem set. Yep, 1600, and there is a contest on 6th of November, right there. But yes, there's also this one, and in which they have like testing new problems. These problems are of communication type. Like they are introducing new problems in which your program runs twice. Once it runs and it outputs something, then based on the output of the first run, your the OJ, the online judge, takes the output of the first thing, and then when your program runs again, based on your first output, generates some new input and gives that back to your program. And yeah, your second program runs and gives the output, and that is the output which is checked. So yeah, that is the new kind of problems they are launching, and it is just making the communication process a bit more complicated, but that is fine. They will be able to uh, fight cheaters that way. So that is nice. 1600. And yes, contest in like 2 days, 6th of November, day after tomorrow. That would be nice. Apply. Shit. Uh-huh. Okay, cool. I haven't done a lot of problems. Wait, I actually have done quite a few problems here, which is kind of crazy, and maximum product strikes back. Okay, I did this once and wrong answer on test case 14. That is crazy. And 8th of October, 1 month ago. Anyways, let's do this one then. Stopwatch, and we will begin. And yep, I don't have the headphones on, so it kind of feels a bit strange without noise cancellation. But okay, you are given an array A consisting of n integers. For I in the array, the following equality is true: every element is between -2 to 2. You can remove any number, possibly 0, of the elements from the beginning of the array, and any number 0, possibly 0, from elements from the end of the array. You are allowed to delete the whole array itself. You need to answer the question: how many elements should be removed from the beginning of the array, and how many elements should be removed from the end of the array, so that the result will be an array whose product multiplication of elements is maximal. If there is more than one way to get an answer with the maximum product on it, you are allowed to output any of them. The product of elements of an empty length should be this, assumed to be 1. Okay, so yeah, we like don't want a 0. So we can split the whole array whenever we see a 0. So we have one sub array on this side and one sub array on this side. And for each of these sub arrays, we will see what is the maximum possible product in this range, which makes sense. Yeah, what is the maximum possible product in this range, right? Like for this range and for this range, what is the maximum product? And if we get, yeah, we can compare all of the maximum products, then it is okay. And if the product of a subsection is like negative, then we have to remove one only, like the first occurrence of a negative number from either sides. Like here, since we want to make this product positive, we can either remove this one or this one, the first negative numbers from either side. And yes, and if we do remove this one, then the product would be this much. And if we do remove this one, then the product would be this much. Yeah, that is nice. But we are not shade, but we cannot just keep multiplying 2 into 2 into 2 into 2. That would be kind of crazy. The only thing that is increasing the product is the amount of twos that we have seen in a particular range. So what we can do is we can make two arrays. One array will contain one prefix array will contain the number of twos that we have seen in a given range, and then another one would contain how many negative integers we have seen in a given range. So that will be next. Hello, I am amazing, and how are you? We are solving good questions now, so that is kind of cool. Emacs attach ECP. Yes, this was a question I was doing before this. CPP, boilerplate, int n, take in n, cool, and then the array itself, right? Vector int a size n. Yep. For int reference x in a, c in x, cool, makes sense. Now we need two prefix things. Count of, like, yeah, count of 2 makes sense. Size would be n plus 1 because we want this to be a kind of prefix, and count of like negative count. Size would also be n plus 1. So then for int equals 0, I less than n, I plus plus. And also we will like to keep the count of zeros that we have seen. That makes sense. Yep. Vector int, or not count of zeros, but indices of zeros. Zero is one element, and the first zero that we see was at -1. -1 makes sense, right? And yep, C2 I plus 1 equals C2 I plus, if the current thing is a 2, then we will add this, yeah, or at least the absolute value, because this can also be a negative. And also count of negative I plus 1 equals C count of negative I, the last value, plus if the current value is negative, which would be AI less than 0. If AI less than 0, then increase the count, makes sense. And also if not AI, if the current thing is a like 0, then zeros zeros dot push back, like I is a place where we have a 0, and then we will also put zeros dot push back n, like the boundaries, makes sense. Yo, shit, that's Parik. That is the first time I'm seeing this name. Hello, new viewer. Uh, we have zeros and everything, and this is the question. How you get good at DSA? It is too difficult for me to solve lead code problems. I know C++ and Python. Well, I think you can begin by saying that you can begin by not saying that you know C++ and Python. I know. Uh, Because if you are saying that you know C++ and Python, then you have like already stopped yourself from learning more because you already know C++. Right? And even I cannot say that I know C++ after reading the C++ book, like half of it. So you can stop saying this, and then just do questions, and do questions which are at your level. Yes, a little wink there. Yes, and I would say be humble. Be humble enough if you do not understand a very, very basic concept, even if other people are talking about that concept as if it is like the most obvious thing in the universe, then still, if you do not understand that concept, then be humble enough to go to Google or to like Chat GPT or somewhere and learn about it, understand that concept. Like today, I was reading about binary search. Right. So yeah, that is, you have to be a bit humble, and yeah, don't say that you know things. Well, if you do know, then you do know, and just be humble enough and learn get your basics pretty good, I would say. And there is one concept which is like very important, and that is invariance. Invariance in loops, it is like in the CLRS book in one of the starting chapters. Yeah, loop invariance. This is a pretty cool thing. Insertion sort. Yeah, you can read this getting started chapter from this book, and there is this concept of loop invariant, which is very important. This will not just help you in loops, but this is a very important general concept which is going to help you like in a lot of things. So that is a good thing to have. And back to this thing. So we have two prefixes. That is nice. And what we will do is we will go through all the subsections that we have created, and we will find the one that is best. And why is Excalibur looking like this? Okay. Our original array was something like this. And then we have divided it into parts. Whenever we see a zero, we have divided that thing into the parts, and now we need to figure out what is the best part. That is the whole question. Cool. And we cannot just multiply everything together because you can at max multiply 2 into 2 about 31 times before overflowing. So yeah, we will be counting the number of twos because the number of twos is the only thing which is increasing the product. Okay. So for int I equals 0, I less than zeros dot size I plus plus. Not even zeros dot size. We'll consider the first occurrence in the zero as the start and the next one as the endpoint, and this would be defining our segment, and we will not go to this last occurrence of zero because there is nothing to its right. Makes sense. And we need to write a function. That function will give us, let's say, three things: tuple with three integers. Yeah, tuple with three integers. That is what will be returned. And let's say using tp equals tuple with three integers, a function which returns tp, and yeah, that is it. We can make this array a global array. Yes, that makes sense. And when we see n, we will say a dot assign n. Makes sense. And not just assign, we have to say 0. The value which is assigned to every n is 0. Okay. And then we have a function which returns a tuple, and we call it find best, and it takes in a integer. Not integer, it takes in two integers, int j, and the range is I and j, I till j, where I and j both are inclusive. Makes sense. Let's say j is not included. Yeah, cool. Cool. J is not inclusive. So first of all, we have to see the product, like the count of twos that we have, int shape. And if we are going to do that, we need these things to be available in that function. So we'll make them also like available here, except the zeros function. Zeros can come like, yeah, later. And when we say this, we will also be saying c2 dot assign n plus 1 comma 0 makes sense, and C, count of negative is, or instead of C1, C2, prefix sounds like a better name, substitute C underscore with prefix. Yeah, good. That is actually awesome. Here also, substitute. Wait, there was a command. Hello. I do not do a lot of lead code, but like if I see a nice problem someone sends on the chat from lead code, then I do lead code. That is it. And how to rip the last vim command. There was a command. Oh, shit. No, yeah, that is wrong. Substitute. Yes, the last thing with prefix makes total sense. Okay. And now prefix is available there. So we will say count of 2 equals prefix j is outside our range, prefix to j minus, yes, prefix j to j minus prefix I minus 1. I minus 1 makes sense. I minus 1 makes sense. And j is not included. That also makes sense. Okay. So that is the number of 2's that we have. And yeah, and in this tuple, we will say the first the first value would be the count of 2's, right? And second would be the start index, and third would be the end index. Cool, makes sense. So we have the count of 2's, and we have, yeah, we have the count of 2's. Now what we have to see before returning this count of 2 is see the count of negative numbers we have. Count of negative numbers in this has to be even. So prefix neg j minus prefix I minus 1, or like prefix negative r minus 1, and here we have 2. Cool. Now if Cn is odd, the amount of negative numbers we have in between this whole thing is odd, then we have to remove something. So what we will do is we will start moving from the left index till we find a negative number, right? And yeah, till we find a negative number. So in L equals I is included, so I. So okay, while we need access to A, which is available, while AI is greater than 0. There is no 0 in here, so that is nice. While AI is greater than 0 and I smaller than J. Right, J is not included. While I is smaller than J and AI is greater than 0, we'll do I plus plus. So when we are outside, I plus plus. So when we are outside this thing or state, L instead of I. When we are outside, and since we do know that there is at least one negative number, so this would be it. And we can do the same thing with the right pointer, r equals j minus 1, because j is not included in the thing, therefore we will start from j minus 1. So while j is greater than or equal to I, which is the left thing, and a j, shit, not j, it is r. Yep. While this thing is greater than 0, we'll do r minus 1. Cool. And let's see now from now L is now pointing to a negative number, and R is also pointing to a negative number. Now we just have to see which range is better. And if this was not the thing, we would just return the first value, which is going to be the count of twos, which would just be count of twos, and the starting index for this thing would be I, and the ending index would be j minus 1. And yes, the starting and the ending index would be inclusive. So yes, minus 1, minus 1. And wait, is that an yes, cool. After this, we have to see here which range is better, and the demographics of the whole thing are like this. Originally, range was between I and a bunch of things, and then j, and L is pointing to the first thing from I, which is a negative number. L is somewhere here, and R is pointing to the first number coming from the right, which is a negative number. So yeah, we just have to see which range has more number of twos. So if the range from L to R, L is not included. So the range from L to R will have prefix 2. L is not included. So L is not included. Shit, L is not included. So I messed up here. I is supposed to be included. So we don't do minus 1. That does not make any sense. Yep. And here J is not included in the range, which, yeah, this makes sense. This makes sense. And J is not included and I is included in the final answer. Yeah, makes sense. This is cool. And here the right limit is again J, and we minus the fix 2 of L plus 1, where L is not included. If this thing is greater than our second thing would be prefix 2 of R, where R is not going to be included. So yeah, this is fine. And the left value would be prefix of I. Right, cool. Well, if this thing is true, then we will return, or we can just say C2 would be equal to this thing, prefix to J minus prefix to L plus 1 makes sense. And I, we will change I would be equal to L plus 1, and J is, yeah, J is correct. Else, if that is not the case, then C2 would be equal to prefix 2 of R minus prefix 2 of I 4. And here left range is same, but the right range J has become equal to R. Cool. And at the end, we are just returning this thing. Okay, cool. After this, yes, we will be calling that above function here. Right. So, and best, yeah, and best initially equals 0, and best initially equals 0. And if the whole thing turns out to be like 0, what if in our range we only have -1? Like, this is the whole thing that we have. In that case, like, yes, this would be passed on to our function, and yes, this would be passed on to our function. And our function would say, I guess, 0. Yes, our function would say count of 2 is 0. That would be the power of 2. And what would I and j minus 1 return? Well, since we have a odd number of negative numbers in this range, then left would be pointing to that thing and R would also be pointing to this thing. L and R both would be pointing to this thing. And here we will say this is 0, this is 0. So we'll come here and J would become equal to R, this thing, and our final thing would say remove everything. Okay, cool, makes sense. That would work. So west and in left equals 0. That is, we are not removing anything from the left initially, and right also equals 0. And TP or auto, can we do auto? I think we can do auto. Auto and count of 2's I, not x comma y, let's say. X comma y equals find best with I and j. Yep. Find best where the left value is zeros I plus 1 and the next value is zeros I plus 1 internally. Yep. And yeah, that is cool. Now we have to compare if C0 is greater than the best that we have seen till now, then C2 equals or best equals C2, and we have to update left and right. Since X is going to be inclusive from the left, we are removing X things, and right is not going, Y is not going to be inclusive. So from the right, we are removing N minus Y things. If R equals N exactly, then we are not removing anything. So this makes sense. This makes sense. Right. At the end, we will say L and R makes sense. C out, left space, right. That should hopefully line 40. Okay, we messed up big time. We did mess up. This should be ESSIGN, assign, right? Assign n plus 1 comma 0. Prefix negative and everything is somehow 0. That is nice. Hello, you have been here for the second time, I guess. Hello, how is everything going on? And it's you are still calling me sir. That is like too much respect for a single human being. Okay, this is somehow wrong. We are always saying 0. If C2 is best, let's say what is C2? Let's say uh, we just have one test case with 5 numbers and they are minus 1, 2, 3, 2, minus 1, 2. Right, shit. C2 was equal to 0, which is crazy. This makes so much sense. Shit. Everything should be defined earlier and here zeros, or we will create a vector integers of integers, zeros which just has one element which is minus 1. Wait, not, it's minus. And when we are calling the function 0 I plus 1. Cool. And let's say 0. Let's see. Okay, this is wrong. This is 03 and 00 2 1 0 1 1 1, which is okay. Let's use a custom example. See out some debugging. Compile. We have just one test case which has three numbers: -1, 1, 2, -1, and this is 1, which is right. But why are we saying we want to remove one thing from the right? Shift, because end index is inclusive. Inclusive. We are not going to remove the end index. Therefore, here we will do n -1 -1. Makes sense. Okay. In this one, this is 3 0, which is the second one. This is 3 0, which is actually true. Very true, because wait, 3 0 is one thing, and we are saying 0 0. Okay, 0 0 is uh, not a very bright answer. 0 0. 0 0 actually is not a very good answer. 0 0 means x, yeah, 1. Shit, yes, that is correct. Or instead of doing this, we can say best is -1. And what if we have just zeros in the whole thing? If we have just zeros in the whole thing, then this will break. This will like actually break. So we can check. Others initially was equal to false, and if so else others equal true, and if not others, we will say if there are no other things, if there are no things other than 0 in the whole thing, then we will say remove everything. We can just say n space 0 new line and then return. Cool, cool. That is correct and should actually work. We'll see. Why short stream yesterday? Yesterday I like ended early. Yes. So that is not a very good explanation. But yeah, I stopped for a while, but now it is okay. And shit, Code Force is messing up again. Sure, yes. Cool. Shit, this is literally not loading, which is crazy. I believe the answer is here correct. Wait, yeah, cool. Maximum product strikes back. We cannot just multiply everything together because we cannot multiply everything together, because right, we can have 10 to the power 5 elements, and if all of them are equal to 2, we cannot multiply them. That would be crazy. Select file and submit. That makes sense. Shit, I don't even know the name of the file. The maximum product strikes back. Shit, yes. documents. This is very crazy. Where is okay? It is working. This is no. This is not working. There is nothing to select in here. And how is everything going on with you? I said I haven't been able to stalk you for a while. So yes, how is everything going on with you? If product is negative and remove first negative from the left or first negative element from the right. Yes, absolutely correct. Nailed it. You can solve 1600 rated questions. Almost there. And okay, let's see. Okay, that is sad. It is stuck. And also, to define the range in which we are looking, we just take the vector which has been given to us, and there are going to be zeros, some elements, one, two, something, zeros scattered. So wherever there is a zero, we are splitting the whole array into two parts, and this is one thing, this would be one thing, and this would be one thing. And since if there might not be any zeros in the whole thing, we are assuming that there is one zero here before the whole array and one zero here. So that if there is no zero in the whole thing, we consider this thing as a segment. Like that makes sense. Yo, how is everything going on? Hello. We can directly submit from VS Code. Shit, that is crazy. Going good in correctly not solving incorrectly not solving CF problems. Okay, that is okay. Accepted. Cool. Shit. Okay, let's go. And yes, this was our earlier problem, but now it is okay. Let's see the tags, brute force implementation, two pointers. Two pointers. They are using two pointers. We are also kind of using two pointers, but we have simplified the whole thing by splitting the array at zeros. So that makes sense. And shit, the solution that you sent, Eric, on Discord about three pointers, that was crazy. I have not thought, never thought about using three pointers. So that was a new thing. Uh, you'd call it a novelty. Good, studying something else for now, but soon getting back to CP. Yeah, always you can, like, there is no time limit, right? So that is nice. And this will be green now. Yeah, cool. Let's go. And do re mi's IQ. Shit. Let's do this one. Buy best watches, best price in India. Yes, of course. Doremi is asking to test any contests. Here is the question. Let's go. Doremi is asking to test any contests. Contest I can only be tested on day I. The difficulty of contest I is AI, okay, and can only be tested on day I. Difficulty is AI. Initially, Doremi's IQ is Q. On day I is Q. On day I, Doremi will choose whether to test contest I or not. She can only test a contest if her current IQ is strictly greater than zero. Okay. If Doremi chooses to test on I, okay, what happens if the difficulty of this current thing is higher? Feels she is not wise enough and Q decreases. Otherwise, nothing changes. If she chooses not to give a test, nothing changes. Okay, Doremi wants to test as many contests as possible. Please give Doremi. So her IQ is never increasing. Shit. So we can just go through the whole thing and count all the things which are smaller than Q. Shit. Is that not the answer? Here too. Okay. Yes. Don't give that. This thing will not affect. This thing will affect. This will also not affect her IQ. Okay, she wants to maximize the number of tests she can give. Makes sense. Okay, so yeah. So whatever IQ is, she can always give that number of tests before the end. So that is kind of nice. So our answer will be before that, right? And yeah, shit. But she might decrease all her IQ before the thing starts. Here, and two tests here. Maximize dynamic programming. If she gives tests on her test on this day, it depends. What is the maximum number of tests she can give in this range? But what is the maximum number of tests she gives in this range? Right. And what would her IQ be? Well, she would use all of her IQ up in just this range, or in just this range. She can give 4 tests, and she will not give this test. Okay. Okay, if she gives this test. So for if we do use dynamic programming, but this we cannot just use dynamic programming everywhere. Here, whether we give test on this day, does it depend on what we have done? mm, Like what is the best thing here? But she would rather give tests right now. Yeah, she would like to give tests right now. Two is the maximum number of tests she can give, which are above her IQ. Okay, so answer is at least equal to Q. Q or N, minimum of whatever the thing is. Answer is at least equal to this. And right. But if she gives these tests from the end, and for all the things before, if she only gives the tests which have a higher IQ, but that would also fail. A greedy algorithm seems to be failing here, like mm, Doraemon's Doraemon's sister, actually. But that is crazy. It is not available in okay, you can laugh. Why is she taking our help when she got Doraemon? I don't know if this was written by an Indian person or not. Forces around, like not tutorial at the announcement. I guess no. I think yeah. Anyway, back to this thing. Back to the question. Let's take one of the examples. So whether she gives test on this day or not depends on her IQ. Okay. If she can have two things from this previous subproblem, right? She can have two things from this previous subproblem. Uh, if she chooses here at this point not to give the test, then she can afford having a IQ of 0 from by achieving like the maximum number of tests from this range. she can afford to have a IQ of 0 because she's not going to give this test anyway, so that is fine. But if she decides that she wants to give the test on this day, then she wants to find the best possible answer from this range when she and where Q is at least equal to 1. Q is greater than equal to 1. And this gives the best value. But let's say we do find that thing. Okay, shit, there are just a lot of sub problems because we could say that we want a IQ of at least Q equals greater equals 1. Here we could want the same thing here, we could want the same thing here, and these things like are not talking to each other. Makes sense. That makes sense, I think. Yep, that does make sense. Or maybe we can increase the number of sub problems. N is 10 power 5. N is 10 power 5. We cannot go N is square. Cannot go N square. Okay, should cut it off. Q. Q is the minimum answer. And she can give all the tests where Q is greater than or equal to AI, right? So yeah, the answer is this and this minimum. When would she, yeah, and giving these tests is not decreasing her IQ. So she can always give these tests. So answer is minimum of this number. Right, right, right. Makes sense. Makes sense. Answer is minimum equal to this. And in our whole array A, we would like to give these Q tests here. And there are some values, A something something, AX, AY, AZ, which are smaller than Q. So we would give this test anyway because Q. So in that scenario, we could say like if this was right here was AQ, the qth number, we could say since this test we would be able to give anyway, let's increase this range by 1. So we have to see how much we can increase this range, the ending range, and still be able to give all the tests till the end. Or is till the end the right approach? The order does matter. The order does matter. Yep. The maximum from the left, the maximum. This whole thing, there are n elements, makes sense, right? And she is by default going to give q of them, and there are some a values which are smaller than q, so that is nice. Why and when would we like to increase this range? We can increase this range depending on the last number. Depending on the last number. Let's say, shit, we can begin with q equals some number like q dash equals, let's say, 0. Let's say 0, or if q was equal to 1 at this point, and is q at least equal to 1? Yeah, q is at least equal to 1. If q was equal to 1 here, and this number here is greater than 1, then we can suppose that we would be giving this test, and we will go here, and on this point we will increase q dash by 1. Q dash would become equal to 2, and here we will compare this element, and we will keep going forward. And if the current q dash that we have, if that is smaller than the number that we are seeing here, then we will increase that number, then we will increase q dash by 1. And if the current number is smaller than or equal to q dash, then we will not increase q dash, and we will just move on to the previous element, and we will keep doing this till q dash is smaller than or equal to q. And once q dash does become equal to q, till equal to q, we will see all the elements onto the left of the point that we left, that are greater, that are smaller than q dash, that are smaller than q. Makes sense. I cannot prove this, why this would be true, but that seems to be right. Not n, but there is also q. Yep. Seen n and taken q vector in a, right? In reference x in a, c in x, yep, and in L, let's say n minus 1, the last thing, and in q dash, literally q dash, equals 1. And while q dash, q dash is smaller than q, and L, shit, I think we should not use dash here. Is smaller than q, and L is greater than equal to 0. Yes, we'll see how far can the end thing stretch, right? So if a L greater, strictly greater than q dash, then q dash plus plus and L minus minus. We'll move to the left, and we will do L minus minus. Either way, does not matter. And if else, then nothing. Just go to the left. Right, makes sense. And if at any point q dash does become equal to q, we will stop. Okay, cool. Cool. And yes, we are supposing that the L element that will come out, when we come out, the L element is not included in the range. That would be nice if the L element is not included in the range, because if everything is like doable, then L will become equal to -1, and that is bad. So L element is not included. So here for and I equals 0, I less than n, I plus plus, and here in rest equals 0, and yeah, wherever currently L is pointing to, we will go inside this loop if there is some element on the current L index, and also we have available Q to ourselves. So yeah, which means the current L is doable. That makes sense. The only thing that does not make sense or like is error prone is how we are entering the starting position. We are keeping the invariance. The invariance is L is pointing to something that is not accounted for. At the start, if L is not accounted for, if this current L is not accounted for, why do we say Q minus minus? That does not make sense, right? Yeah. Yep. If we have something like 1, 1, 1, 1, 1, and Q equals 1, we will start Q dash at 1 also, and we won't go past this thing. So we will miss this last element. Makes sense. Yeah, this totally makes sense. So what we should do is make this equal to 0. Q dash will begin at we can AI equal to 0. No, AI will not be equal to 0. So that is kind of nice. Q dash equals 0. So initially we have not accounted for anything. Yeah, initially but it's still, the problem is just with the invariance and L less than equal to L. And yep, we are only moving forward if the current L is accountable. So rest is pretty cool. And yeah, for in we are already if AI is smaller than or equal to Q, then rest plus plus. See out rest, and hopefully this does not work. Okay, shit, this is not we are going to. Shit, okay, that is crazy. That is crazy. We do not have to output rest, we have to output if we are going to give a certain test or not. Shit. But even in that context, these answers are wrong. The number that we have outputted should be equal to the number that we have outputted should be, yeah, shit, equal to the number of ones there are. And this is not right. This is wrong. This is not right. Yep, this is wrong. Rest size is n. Initially, everything is 0. And we'll remove this rest and we will say, since the current L is pretty cool, we will say L equals 1. Rest I equals 1. And yeah, 21. For int I equals 0, I less than n, I plus plus, C out, rest I with a space or a new line, where when I equals n minus 1, not n minus 1, but L, we are going till L. Um, we are going till n without space. My bad. Why would this be 0? The second number. This starts at 1. Q dash starts at 1, and I think that is wrong. We have not established a right invariance. L is right. So L means the current thing which has not been accounted for. What is Q dash? Q dash would mean the current value of Q. Okay, last one is correct, and this one is also correct. Three things, two things. But this is like trial and error. Trial and error is not a proof-based thing. And where is your headphones? My headphones are like s- somewhere else. I'm going to be streaming without the headphones, which seems much better. I mean, headphones have noise cancellation, and that like was not feeling quite bit right. This looks better. Okay. So for int I equals 0, I less than n, I plus plus, and shit, all caps, mad villain, all caps. We are getting the correct answer here. Wait, are we getting a correct answer here? Well, the last one is like correct, even the test checker says. And here 1 0 1 1 2. So we can give the first one, and we will not give this one, but we will give this and this. Okay, cool. Here we will not give this, but we will give this and this. Okay, that is also right. That is also right. That is also right. And here we can give both of them. Should be able to give both. Yes, we are giving both the tests. That is nice. Before the starting of the loop, L is pointing to something that is not accounted for. That makes sense. And what is Q dash doing? Q dash means the required amount of Q to get through the things that we have gone through till now. And since initially we haven't gone through anything, so this much makes sense. And when our required amount of Q gets equal to Q, the actual Q, we'll say that the current thing is not accounted for. We cannot increase our Q further than this. Then we will see how many things on to the left or till the current L, because L is also not accounted for, are smaller than or equal to Q, which we can do. So yeah, this seems right. This seems right, but this could also be very well be wrong. Sir, I am a noob. Shit, don't call sir, and shit, Shonak bro, you are all right. You are all right. I mean, okay, if you are a noob, that is nice, because like if you are a noob, then nothing would happen. If you just say that you are a noob, you can work hard and study to change that. I, that is one course of action you could take, or you could just say I'm a noob. That is also one thing. And shit, and I hope you don't get wrong answers. Okay, shit. Okay, shit. Okay, amazing, amazing. If this actually works, I would have to see like what what they are doing in the problem. Remy's IQ. This would also prove our IQ. I still am not very sure if this will work because I didn't prove that this would work. This does work, but why? Before reading, I would like to see why does this even work? Why does this even work? And how did I come up with this specific solution, which is it just happens to be correct? I think, yeah, one of the things was that I was thinking since there is q, we can always give the last q things, and I was thinking about how much can we extend this q to the left, right? Yeah, makes sense. So instead of thinking from here down the row, I started thinking, let's suppose we have some imaginary q, the required amount of q, with with which we start from the end, and we will see how much q dash is required to get as far as we can get while this required amount is smaller than the given amount. And when we have reached our limit, like we cannot go more towards left, we will see how many on the left we can just give because their difficulty is not too much. And out of the context, these things don't make sense. But yeah, when will you start giving contest? Day after tomorrow, 6th of November, there is a contest, and shit, I'm afraid, but that would be fine. Let's see. Okay, what would this be? This would say, I would guess, implementation to predict or guess this thing. This would say implementation and implementation, because this doesn't seem to be any general thing, or maybe two pointers off chance. We can apply binary search. Greedy, yes, greedy, yes, greedy. Greedy is one thing. Constructive algorithm implementation is there. Greedy, yeah, this is greedy, but I don't know how we can apply binary search in this. Maybe we can apply binary search here. We can see, we can choose how far we can extend a thing from the right, and see, are we able to go through all of the elements towards the right? Shit, we can apply binary search. Shit, yes, we can apply binary search. Let's apply binary search in that case. We don't even need the resolution thing here. For int reference x in A, C in X, right? Int L equals 0 and R equals n minus 1, or you say that R is never the answer. No, no, shit. Now the terms have tabled. The terms have tabled here. Uh, in this binary search, we have true for some point, and then we start getting a false. We are looking for this first occurrence of true. So we are saying R is always pointing to something that is true, and L is always pointing to something that is always false. Since this last element is always true, since Q is always at least equal to 1, so this thing is true, R can point to n minus 1, and L, there is a possibility that the first element is also true. So we will say that L points to -1 at the start, which makes sense. Yes, binary search on answer. Yes, we will apply binary search on answer. That makes sense, right? R would be equal to n minus 1 and L would be equal to -1. Okay, so our range here would be L to R, where this is half open, L is not included, but R is included. So while R minus L greater than 1, we will do, yeah, and M middle value equals R plus R minus L divided by 2, and let's say bool BS on answer. Just the thing that you said. Hello, how is everything going on? Rahul Sharma is 0Q2UL on answer. This will take in a certain index, let's say, and tell us is this thing true or false. Good, makes sense. Makes sense. And shit, binary search is actually simpler than the one that we implemented. Yeah, yeah. I mean, no, they are of same difficulty, I would say. Complexity, not difficulty. A dot A dot assign size would be n, and initially every value is 0, right? And we also need q, which we can just pass in, or we don't need to pass in. We can say int q, and here we won't say q, right? So q is known. Okay, and we are saying I is included. What is the answer for I? Right, right, for q dash equals q. I less than n I plus plus. What is n? That makes sense. And n equals a dot size. What is a? That is also a nice question. Vector and a. Initially nothing. Right. Cool. And now if ai is smaller than q, or smaller than or equal to q dash, ai is smaller than equal to q dash, then it is okay. But if ai is bigger than q dash, then we will have to do q dash minus minus, not double dash, single dash, minus minus, and yeah, that is nice. At the end we will return true, but before that we will see if there is some element left, and if not not q dash, then return false. Yeah, that is kind of nice. And if bs on answer for I or m, if the current thing is, if the current m is true, then we will say r equals m, else l equals m if the current m is false. Yeah, we are looking for the first occurrence of a true. That makes sense, and that would be equal to r, right? That would be equal to r, and yeah, then we can just start outputting the answer in I plus plus. And yeah, if if either ai is smaller than q, smaller than or equal to q, or I greater than equal to r, we will output 1, else output 0. Here output a new line, and no segmentation fault and anything. Um, okay, we messed up the binary search. We messed up the binary search. That is crazy. I did backwards pass for this. Back shit. I also did that. Shit, that is called backward pass. Okay. This thing. I think. I mean, I don't know this by name, but is this also a backward pass? We like the last index is initially equal to n minus 1, and l is not accounted for, and this is q underscore, which is the required amount of q to be like to give all the l tests, and we are always going back, and after that we are seeing till equal to l, how many q's are how many values of a are smaller than or equal to q, they will be equal to 1, and then this. I think this is called a backward pass. That is crazy. I mean, I just saw here, shit, that was something, binary search, and I thought, why not? Let's apply binary search. And somehow binary search is wrong. It's not q dash. Okay. Q dash is equal to q. Shit. Why are we even initializing I? Makes sense. Yeah, cool. Cool. 2101. Yeah, yeah, cool. Makes sense. This should hopefully work. Hopefully, that is. Let's see. Backwards search. Shit, that is much faster. Or at least it appeared to be much faster. That is cool. That is cool. Backward search. Okay. Now the tutorial for this. Dorimi's IQ. This was just question number C. Uh, this was question number A. I guess in division 2. Solution 1 and solution 2. And login. This is the second one that we implemented. Yeah, this is, yes, this is second one that we implemented, and this is the first one that we implemented. We call contests that will decrease Doremi's IQ bad and the other one's good. In the best solution, testing the maximum number of contests, there is always an index x. X less than equal to this is tested if I is good, and every I equal to or to the right of x is tested no matter what kind of contest it is. How to prove that this is conclusion? Yes, that is the thing that I was afraid of. How can we prove this conclusion? For any choice, we find the last contest A that is not tested, that is last contest that is not tested, and the first bad contest B that is the last contest that is not tested. Okay, and the first contest B that is tested. So if B is smaller than A, okay, then we can give up contest B and choose to test A. Makes sense. Makes sense if makes makes sense if A is the last contest which we have not given up, which we have not given, then we can, and B is the first bad contest that we have given. Instead of B, we can switch the whole thing towards the right by one element. Makes sense. And the number of contests that is tested does not change. Yes, that is true. If B is to the right, then what then does not this does not then this does not even make sense. A is the last contest A that is not tested. The last shit. If A is not tested and we are saying that B is higher than A, B is towards the right of A, then this does not make sense, right? Because we are saying nothing towards the right of A is tested, and if B is tested and B is to the right of A, this seems to be a invalid thing. When X is smallest, you can get the best solution. X, there are already an X valid. There is already an valid X. There is already a valid X. Okay. You can get the best solution. Because small x would mean it is towards the start of the vector. As you can find the smallest by binary search. Okay. Let's see how they have implemented this. P, Q. Okay. We are taking in sum and in Q. Okay. I from 0. Okay. They have made this one index. Okay. Right. A, and there is also B. So sum equals 0, and okay, for every index from starting from the last one, if this value is smaller than equal to NB, then we can give the current contest, that does not matter. Else if IQ, which has been given to us, initial IQ is smaller, then we can increase the needed IQ. Shit, N might actually mean needed IQ. We increase needed IQ and BI equals 1. Else BI equals 0. That is true. That is very true. Makes sense. Let's do more questions. We have done 2 questions, which is nice. Let's have our target. 4. But the first question was like, I had already attempted that question last month. Let's do a decode. Shit, decode. I was reading about codec in the morning, so decode looks nice. Decode. Okay. Yeah, cool. Stopwatch. Cool. In a desperate attempt to obtain your waifu favorite character, you have had okay. You are given a binary string S of length n for each pair L2R. Count the number of pairs X, Y within that thing such that the amount of 0 equals the amount of ones in the substring. This. Hey, that is that crazy? Here 0, here for each pair of L and R. We have to find the answer. That is cool. Or instead, we could find, first of all the pairs of L and R, let's say, in which the count of 0 equals the count of 1. And then we can see for like how many pairs, or if we were to take this terminology, X and Y, we can first of all see how many, or like for each possible X and Y, for each possible X and Y where the count of 0 equals the count of 1, how many L and R is this X and Y part of? And that would be, since we know X and since we know Y, let's say this is 0 indexed. If this is 0 indexed, on to the left, we have X plus 1 possibilities to choose from, and on to the right, X plus 1 on to the left, and on to the right, we would have, since this range, X and Y is included, onto the right, we would have n minus y possibilities. So in total, for every pair of X and Y, where X and Y are included, and the count of 0 equals the count of 1 in this range, C0 equals count of 1, the answer, that the amount by which this thing would increase the answer would be X plus 1 multiplied by n minus y. This many numbers onto the left, this many possible choices onto the left, this many possible choices onto the right. Response plus equals. But now comes the more difficult part, which is finding out all of these X and Y's. We cannot brute force. Yep. Which is like the first basic instinct of brute forcing. What we can do is 2 pointers. Okay, we'll have to use some sort of 2 pointers here. Let's say this. Let's say we find the first valid pair of X and Y, which in this case is this. Makes sense. Makes sense. Right. If this is here, or we can use a map from the size. If we know the size, it does not help. Yeah. If you know the size of a subsegment where the number of zeros equals the number of ones, then it does not actually help. Let's first at least check if our hypothesis is correct or not. Here we are saying this is one valid range. This is one valid range starting from this zero. This is one valid range and this is one valid range. And starting from this one, this is one valid range. Or I think we might be going in the totally wrong direction. That might be the case. This is one range and this is one range. And then if we start from this one, two ranges for this. And then if we start from this 0, this is one range and this is also one range. And if we start from this one, this is the only range. And if we start from this final ending last 0, this is the only range. Okay. Yeah, that is going to be too big because we have to go to each range and find out x plus 1 multiplied by n minus y. So instead, yeah, that would be kind of wrong. That would be wrong. Yep, that would be wrong. So instead, we can simply ask if we but yes, the thing is, when we are, this one range is going to be added or counted again and again, like multiple number of times. And this range, every range is going to be counted multiple number of times. This small range will be counted for when L equals this and this, like for every value of L and R, which is a superset for this range, this thing will be counted again and again. So we cannot just say for a given L what is the best R or even what are the possible number of R's for this given L. Maybe we can use a stack in some way. Why would we want? Okay, what do we actually want and what do we have? I have to like think about this. YouTube is annoying as shit. I cannot turn off live captions. YouTube is annoying AF shit. There must be an option. Why can you not turn off live captions? Shit, live captions are on. That is a crazy thing. I think I can fix that somehow. Closed captions. Shit, there you go. They are off. Yeah, that is off. So I guess it is on your side. You can fix it. And shit. Again, all caps. All caps. This is what we have. Okay. Zero and zero and this one is simpler, 70. 1, 2, 1, 2, 3. This is one correct thing, right? And this is one correct thing, and this is one correct thing. Okay, and shit, it can also be 0. The range can, yeah, the range can be 0. So answer would, at least if n is the thing, if n is the, like, the number of things, then the answer, wait, is, no, yeah, we cannot have a empty range here because L can be equal to R, but L and R both are inclusive. So we will not have a empty range. Answer could be equal to 0, which it is actually equal to 0 in this case. Yes. Let's work with this a little bit. This one looks nice. Here we have just like 5 correct values. This and this. Okay. Yeah. We have just 5 values which are working when x and y are 0 indexed. We can have x equal to 0 when y equals 0, 1, 2, 3, and x equals 1 when y equals 2. That is one thing. And then we can have 0, 1, 2, 0, 1, 2, 3, 4, 5. X equals 5 and 6, 7, 8. Shit, I messed up. 5, 6, 7, 8, 9, 10. Y equals 10 and 6 and 9 and then 7 and 8. These are the possible ranges, and how do they affect the answer, the final, like, total response. We had this formula, x plus 1 multiplied by n minus y, and n here seems to be 11. It does seem to be 11. Yeah. 4 plus 5 plus 1, 11. N is equal to 11 in this case. So if we apply this formula on all of these values, then x plus 1, 1 into 11, 1 into 11 minus 3, 8. Right, for the second one, 2 into 11 minus 2, 9, 18. Cool shit. Okay. And then 6 into 1, that is 6. And then 7. 7 into 2, 14. Okay. And then 8 into 3, 24. And if we sum the whole thing up, we have 8, 80, 40, 16, 56, 60, 70. Shit, which actually is the correct answer. That is nice. Okay. So, what you were thinking at the start, that was correct, but finding out each possible x and y is too much of work, too much work, in the sense that it will take too long. The time complexity does not allow that to happen. We cannot certainly go n square, but the best we can go is n log n. Should maybe we can uh, for, yes, for a given x we would have to go through all the y, but can we avoid going through all the possible y's for a given x? Can we avoid? Because if we were to go by, okay, we have two things that we can do here. We can either go x in starting from x and y and see how many L and R does this, is this xy a part of, or we can go through all the xy, ly, lr pairs and see how many pairs of xy within this lr range are, like, are okay, where count of 0 equals count of 1. But this approach seems better. This seems better, and this seems bad. Somehow this seems bad, and this one seems better, where we are going through x and y. And what we can do is, for a particular x, for every pair of such x and y, we want to do x plus 1 into n minus y. And if we split this, let's say for a certain x1, we have multiple y, which can go through with that x1, y1 plus y2 dot dot dot. We can take this x1 common, multiplied by invite x plus 1, take that common, multiply that by the total sum, which would be n into this. Let's say there are m or k amount of y's, n into k plus y1 or minus y1 minus y2 dot 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 minus yk. Yes, and do this for every x. Do this for every x. And since okay, now that we know this, we can figure out a pattern in the way that we are choosing x and y. Since let's say we have 0 1 0 1, if our x starts here, all the possible y's will be here or here, and 0 0 1 1 here. We can write a prefix containing the count of zeros and ones, and then use that prefix to figure out the number of zeros and ones in a given range of x and y. Y, like always 2 steps ahead. If this is the correct y, then the next y is going to be the current one, y plus 2, the current y plus 2, like that is like the minimum y value. And here, if we do plus 2 here, but here we know that the answer is not right, but then here the answer is right. Alternating, so there has to be a pattern here, but there is no. Hello. Shit, that is crazy. That is crazy. From 200 to 400. That is pretty cool. 400 mark. So now you must have gotten like really good at lead code now. This is cool. And what do you think about this question? And shit, have you given any contests? Like you were saying you have started doing code chef. Have you given contests? That would be nice. And this is the question we are doing right now. I'm still learning. Shit, 400 questions. Okay. At this point, I guess you are more afraid, right? Because 400 questions is quite a bit. I have also only done 400 questions here. 416, my bad. Should that is actually a nice number. 4 and a square of 4. That is nice. I gave 1 and solved one question. You are still learning. I mean, it is a different thing in a contest. A contest is a different thing. You need to have a different mindset, like totally different mindset, because there is time limit, and if you do not solve the question right now or like quickly, then you will get a lower rating, which is something you don't want. So it's like pretty cool for training you mentally, psychologically. And yes, I'm also afraid. There is a contest on 6th of November. Let's see what happens. I'm also afraid, but I will give that contest. You lack in time. I need to improve my typing speed. Shit. Wait, do you do touch typing? If you don't know touch typing, you can start from uh, Typing Club. Yeah, this one, typingclub.com. This is a pretty cool website for learning how to touch type. And then, of course, there are practicing sites. Monkey type. Let's go. Let's like actually go. Okay. Shit. Okay, that is bad. That is bad. I'm also learning. I'm also learning. Mine is also just 80. So yeah, we are on par. So 80 is not that bad. I mean, yes, it is bad if you want to get better. Yeah, it will improve. It will improve. And this question, 200 is crazy. Shit. Okay, I'm not actively trying to increase my speed, but shit, that is nice. That is nice. 200 WPM. That is crazy. Actually. Okay, let's see how much. Okay, let's uh, challenge each other who reaches 200 first. Huh? That is nice. Let's see who reaches 200 first. Right now, I just showed you. Mine is also 80. You are saying yours is also 80. So let's see who reaches 200 first. Cool idea. Yes, let's go. Let's go. I mean, we have to make this official and right, let's go. So yeah, now it is official. Who reaches 200 first? That would be nice. And so back to the future, back to the question. Let's go. Let's see who reaches 200 first. 200 is actually crazy. How people died in 9/11? What the hell? How many people? 200 WPM, words per minute, speed. Shit, that is pretty unique. 0.0013. That is like 13 people in 10,000. Shit, 100,000, 10,000. That is like 13 people in a million. That is crazy, right? 1 million. Yes, 13 people in 1 million. That is great. Yes, we have to start practicing it because we have said, let's go. It is official. Yes, we will be like pretty top 1% of the 1%. Mr. Robot, let's go. But also, solving questions is important. And this one is a nice question. This one is actually a nice question. It has to do something with left and right pointers, which is cool. Left and right pointers. And shit, the brightness is only changing on my side, not on your side. Each test contains binary string. It is guaranteed that it only contains zeros and ones. And yeah, for every possible value of r, for every possible, we do not want to go through all the possible values of y. Let's see how many possible values of y can exist at max, right? If n equals 10 power 5 at max, right? So for Rx would go through all the n possibilities. So that is nice. And for each n, we will have n minus x divided by two possibilities, which is n square, which is yeah, which is n into n minus x divided by 2. This is n square, big O of n square, so not very good. This is not very good. Imagine typing in contest W 200 WPM and solving all questions correctly in first go. That would be crazy. I wanna see. Yep, I will go. Shit, I didn't saw the time. My bad. Washington right now. You are like all over the, not even all over the country, but all over the planet. Japan. You even went to Finland. I guess Scandinavia. That is crazy. Helsinki. And shit. Okay. We do not want to go through all the y values. Okay, let's bird's eye view. We have groups, 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 groups of x and y's. Yes, we have groups of x and y. And yes, we can have something like this. We can have something like this. And in the middle of these things, we can have other things, like in the middle of this one, we can have this one, which would be like 0, 1, 0, 1. Or in the middle of this one, we can have this one itself, 0, 0, 1, 1. Mm, hmm. Okay, right. But that does not actually help. And I will have to go to the washroom and I will be right back in just a minute. Shit. Is there any proper procedure for finding time complexity? Yes, there is proper procedure. December, Finland in December, business trip with your father. My plan is to visit every country before world ends. Shit. I think it might end sooner than we might think. So yeah, hurry. You have to hurry. Leave. The autocorrect sucks. Shit, there is autocorrect on YouTube. That is crazy. Yeah, yes, there is a procedure. You have to see what you are doing. You can try fix a specific interval and count the number of pairs. That is part of we can, mm, but okay, we can fix a number of pairs, fix the size. Yeah, load. We can try fix a specific interval and count the number of pairs that is part of. But the thing is, if I have 0 1 0 1 0 1 and for size equals to 1, or maybe I'm just stupid here, size equals to 1, this is one possible pair and this is one possible pair. For this one is on the left, there's just one possible thing we can choose, which includes this point, and on the right we can choose all of these numbers. So the total number of pairs which this is a part of would be 1 into 1 2 3 4 5. And for this subsegment where the size is 1, this is 1, here we can choose two things on the left, and on the right we can choose 1 2 3 4 things, which is 8. So this one is a part of 8 different things. Yeah, this one is a part of 8 different things, even though the size is same. So like if interval xi has zeros, has equal zeros and ones, then it contributes, yes, yes, n minus y and into x plus 1. Yep, shit, YouTube is drunk. So you can keep a cumulative sum that maintains the number of intervals that you can form for, then you can keep a cumulative sum that maintains the number of intervals that you can form for the ith index at each size, for each size. Cumulative sum. Example, you can keep a cumulative sum that maintains the number of intervals that you can form. Okay. Example, increase by 1 whenever it sees a 1 and decrease by 1 whenever it sees a 0. Okay. 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 And if the cumulative sum ever equals 0, then it is a valid thing. But isn't this bad? I would have to go through all the possible sizes. Well, size cannot be equal to 1, size can be equal to 2, 4, 6, all the even numbers. There are n by 2 possible sizes, and for each size, I go from I equals 0 to I equals n minus the size. And I'm just messing up. Okay. We'll keep a cumulative sum that maintains. Okay, that makes sense from the ith index. So like if this, yes, this also makes sense. You can, yes, the problem which I think is a problem is for a given size. Depending on where it is, the answer changes. What you are saying, we can. Okay, cool. The problem is just counting the number of pairs that have equal ones and zeros. Counting the number of pairs that have equal ones and zeros. We can start an index I going from L to R. Okay, shit. Is just counting the number of pairs that have equal ones and zeros. So like if, okay, you can try to fix a specific interval which you said here, okay, fix a specific interval and count the number of pairs that it is a part of. Or, okay, so you can keep a cumulative sum that maintains the number of intervals. Okay, just consider the easy version when L equals 0 and R equals 1. The problem is just counting the number of pairs that have equal ones and zeros. Hmm, I'm messing this up. We can keep a cumulative sum 9 when R L equals this thing and R is here in this range. How many pairs in this range? How many pairs are like okay? This feels very similar to a question which kind of similar to the AB question which you were doing yesterday. Yeah, yeah. I mean, thank you for all of this. I will figure this out. I mean, yeah, you have lower bandwidth here. You just have text to convey your thoughts. 01. We do not want to go for n square time complexity. Right. I'll go to the washroom and I'll be right back in just a minute. Just 1 minute. And be back. Okay. How would you solve it? The whole string instead, all pairs. How would you solve it if it was just the whole string? Just the whole string. Okay. Instead of pairs of this. That makes sense. That makes sense. Okay, how would I solve it if it was just one thing and I had to figure out how many pairs there are? Should I cannot think of a non n square time algorithm for this. For each index from 1 to n, we're just adding the number of counts that also have the same cumulative sum. with- Huh? For each index from 1 to n, you are just adding the number of counts that also have the same cumulative sum. Okay, that is crazy. Here the cumulative sum is 0. Wait, here it is -1. here -2, here -1, this and this same, and then here 0, and let's say 0, it was also 0 initially. So this and this have paired up. So we have seen -1 two times and 0 two times. There are two things, this one and this one. That is nice. That is nice. What if this was more so that is a nice thing. That is cool. You're adding the number of counts that also have the same cumulative sum. Shit, that is nice. That is nice. If index I and j both have cumulative sum x, then this interval has an equal number of zeros and ones. Shit, that is a new concept. Yes, that makes sense because to get to the same thing again, you went through the same number of zeros and ones. That is cool. Okay. You went through the same number of zeros and ones, and also size. Size would be if the cumulative sum x, all the makes sense. Yeah, this makes sense. This makes sense. This makes sense. So for if we didn't have different LNRs, that is how we would do this. Cumulative sum. Initially, let's say it was equal to 0 initially, right? 0 once, and then when we saw a 0, it became -1. So it was -1 once, then 0 again. So we saw it as 0 2 for okay, and then this -1, we have seen -1 twice in this range. We have seen -1 twice, okay. And then we go here, you will say this becomes 0. We have seen 0 like thrice at this point. Then -1, 0, -1, 0. We saw -1 like 4 times. Okay, so we can by this easily figure out how many pairs have the same thing, right? And the answer for this, if we were just considering the whole thing, would be, since we have seen 0, 1, 2, 3, 4, 5 times, we can pair up any of these zeros with each other. So 5C2. Yeah, the number of ways to choose two things from out of these five. And for this 4C2, 4 factorial divided by 2, 2 factorial, 2, 2, 4, 3, 6. This would be 6, and this would be 5, 3, 4, 5, 10, in total 16 subarrays. That makes sense. That is good. If index I and B both have the similar, yes. So essentially, what you are writing is count of answer plus equals count of C sum. Count of C sum. How many times have I seen this C sum? Comma, count of C sum plus in each iteration of loop. Count of C sum. So we are 1600 now. Good work. Yeah, we are at 1600. We are struggling, but yes, we are here. Struggling is nice. So essentially, what you are writing is answer plus equals count of C sum. How many times have we seen this current sum? And increment the current sum makes sense in each loop iteration. Okay, so okay, yes, we have that. And shit, yes, it will be map. This will be a map. CNT will be a map because we can have negative values. Makes sense. That makes sense, right? So let's say after that we do have the thing, and I will figure this out. Let me figure this out. When we do have the map for a given test case, let's say for this, yes, the count value initially would be equal to 0. Then it would be equal to uh, for 1 we will do +1, and for 0 we will do -1. So 1, 0, -1, -2, or shit. Okay. 0 space 1 space 2 space 1 space 0, so -1, -2 is 3, -4, 3, -3, -2, -1. Okay, which also indicates that we cannot use this whole thing as one of the valid things. Okay, so we have this, and then we will make a map where we are saying 0 appeared exactly twice, and -1, -4 appeared once, -3 appeared twice, -2 appeared twice, -1 appeared twice, and then we have 0, 0 appeared twice, and 1 appeared twice, and 2 also appeared once. Wait, 1 appeared once. Okay. We have this information. If we could have this, this would work for fixed thing. This is just for one range, yes, and it is pretty much the same for extend it to all intervals. Huh. What extension do we have for code forces in submission page? The ratings show in front of each extension. What is that? That is yep, this thing, the ratings, this extension, code forces helper. This is a nice thing. And I would also suggest adding, no, return YouTube dislike. I would say you can add this one, CF analytics. This helps you see the questions that you have solved, like a nice crazy bar for telling how much rated questions you have solved, and topics and the questions which have been unsolved. So that is nice. Okay, this is for one range, but pretty much the same thing for extending it to all the intervals. Okay, shit. Instead, I think instead of saying one, if we keep track of wherever we saw the one, instead of saying just like we saw -4 once. Yes, instead of saying we saw -4 once, we can say where we saw -4, we saw -4 at this index 0. 1, 2, 3, 4, 5, 6, 7, 7. We saw -3 twice here and here. And I've had 6 and 8. Two places. Right. And both of these can be chosen as X and Y's. Right. Uh-huh. And for 2, -2 appeared at 5 and at 9. And then -1 appeared at 4 and at 10. Cool. And then 0 appeared at -1. We could say -1. Let's say 0. We could say -1. -1 is a nice thing. Let's say 0. But what about the 1? Wait, shit. 0, 1. Yeah, we will say -1. We can change the formula for calculating -1 and 3. Shit, this one, -1 and 3. 1 appeared at 0 and 2. And the 2 only appeared once. 1 at index 1. Cool. And we have to pair now all of these up with each other if I'm thinking in the right direction. That is, yep, let's go. Indian lad 47. Shit. AK-47. Looking forward to see your screencast attempting contest too soon. Shit. Okay, I will do that at some point. Good luck, mate. Thank you. Rooting for your insane consistency. Yes, I will not break. Solved like 300 problems in a span of 75 days. Only took breaking break during Diwali. That is nice. That is nice. 300 problems. Shit. And what is the rating of these problems? And at how much rating did you start? And at how much rating are you currently at? The growth would be pretty cool. Okay, we have spent 15 minutes on a single question. Not very good. For these values, X and Y's. You can choose the current index. Zero, 1, 2, 1. Yes, this 1, 1. This 1, 1 is one pair, and this is one pair, and this matches with the first thing here, and this 0, 0. Let's call this C something, C, and C I is the cumulative sum from 0 till I included. K I included. I included. I included. So our range begins from I plus 1. The left thing plus 1. That is our range. That would be our x. Okay, so something is wrong here. Like something is actually wrong. This is the whole thing. Okay. Yes. We can calculate the number of subsegments in which the count of zeros and ones is same. What I'm trying to see is if we, instead of finding the number of times this particular number is appearing, if we can find wherever it is appearing and make an array at this particular key, then we can pair up every number in this thing. But pairing up every number might actually take a lot of time. Right? Like because at max there can be n by 2 numbers in this given range. And to pair up every number, we would have to like have some formula. Yes, we would have to have some formula. Whenever we see a count like -1, we will see how many times have we seen that before. Or whenever we see a zero, we will see how many times we have seen that zero before. And we will have to pair up this number with however many times we have seen the zero before, which is going to be in our array here. But okay, shit. Let's say we are currently at a zero. Yes, shit. Okay, let's say we are currently at a zero and our current index is something, right? And yes, current index is something. We are currently at a zero. Makes sense. And yeah, current index is I. Let's say we have seen zero when the index was something, let's say x1 or x2 or x3. At these three places, the index, the value was also zero. And what this means is x1, x2, x3, and also I. This means that starting from zero, this is inclusive xi. So in this range, the cumulative sum was equal to zero. Not in this range, but yeah, in this range, starting from zero till I, xi or x1 and also I, the cumulative sum also includes the index that it is currently at. So if at some point we have something like this, here we see that this is a valid thing. So whatever the cumulative sum was here, when we are here, it will increase by 1. So C1 plus 1, and here it will again decrease by 1. So it will become back C1. And here our range would be this index, which was, let's say, I. This was, the next one was I plus 1, and the next one was I plus 2. Okay, so that is figured out. So if this index, let's say, was x1 and this was x2, then our range, subsection range would be from x1 included to x2 not included. Okay, this inclusion and exclusion is like always kind of confusing. Not in C, we mostly on lead code. Okay, maybe one D will move to code forces. Code forces is, I would say, much more human, but code forces a bit more difficult because during the contests you have to be in the moment and solving questions, and if you are not doing good, then your rating will go down. Rating is not a very good parameter for judging someone's capabilities, but still, it does matter to some extent. Like if you are good and you do not have a high rating, how is that possible, right? If you are good, then you can increase your rating. Okay, okay. So that would be our range. Okay. Currently, I am at index 1 and I have seen 0 and yes, I am getting somewhere with this. I've seen 0 at all of these indices, which means this current I can go with a couple of things. This is one segment and x2 I, this is one segment, and x3 I, this is another segment. That is cool. Now, for a given segment, what would be our formula to figure out how many bigger segments is this one a part of? So, on to the left, we have x1 plus 1 choices, and on to the right, we have n minus I plus 1 choices, and minus I plus 1 choices makes sense because I is also a choice which we can make, and the last choice I is also a choice which we can make, and also I minus 1 is a choice which we can make. So that is nice. And here, since I is fixed, we can take this common, and what we would be left with is n minus I plus 1 multiplied by 1 plus 1 plus 1. You could say count of the times, number of times that we have seen a 0. Yes, plus all of these indices x1 plus x3 plus x2. Shit. That is nice. That is nice. And we can figure this out in one go. That is cool. We can figure this out in one go. That is, yeah, shit, that is pretty cool. Let's do this. Okay, 1 hour to figure out what to do. And let's see how much time to actually do the thing. And that is nice. And n, take an n, cool, to the left. There is no n, by the way. String s, take an s, and int n equals s dot size. Cool, and we'll have a map, integer, which will be the value there, and pair. Yes, and we will call this np, where the first value in the pair will be the count of how many times we have seen this value, and the second would be the sum of all the indices. Right. So for int I equals 0, I less than n, I plus plus, and also int c or cumulative equals 0, and we'll say np 0 dot first 1 and np 0 dot second equals 1. Yeah, and yeah, we will update the current thing, literally the current thing. Yes. Shit. And also we will update Yeah, let's say Ci. C is the cumulative sum in the range 0 to I. I is not included, which changes the whole formula. If I is not included, this changes the whole formula. I is included. I is included. Okay, shit, yes. You can begin. I from 1 and 2. And we'll see. We will first of all update the current value of cumulative sum if Si minus 1 equals 0, we'll say minus minus, and else plus plus. It's like cumulative sum. And yep, we also have long rest equals 0. And our answer here, let's make this a long answer here would be rest plus equals MP. How many times have we seen this? Dot first plus MP dot second. I mean, yeah, the sum, multiply this whole thing by n minus I plus 1, n minus I plus 1, n minus I plus 1, and MP dot first plus plus, and MP dot second plus equals I plus equals I plus equals I. Yep, yep, plus equals I or I minus 1 plus equals I. Yeah, let's see. Okay. Our answer is always a bit bigger, a little bit bigger. So we are messing up somewhere. When they move to pole forces, yes, very comfortable with medium level questions on LeetCode. Now trying more harder questions. That is good. And hello, good morning. You changed your thing here. It was supposed to be green, but it is now an actual thing. That is nice. Let's stalk. So you have made your thumbnail, that is, or like channel poster. That is nice. And so I is not included. I is not included. We are messing up somewhere. Messier. Shit. Messier 33 or 75 is a star system. We just have to now fix up a little like dials here and there, but the main logic is correct. That is nice. MP 0 dot first equals 1, and MP 0 dot second equals 1. 1 is the count, and shit, how is everything? Everything is amazing. Okay, cool. Shit, that was the thing. Count. Shit. Not this, but this thing should be 0. And I think we can actually merge this whole thing. We can say here MP0 equals 1 and MP come and MP come plus equals 1 plus I. Let's go. That does work. That is nice. Pretty nice. This account is from those days when I had a gaming channel. So you still have a gaming channel. You are not very active and wanted to be a streamer. Shit. There is no competition. And you can still be a streamer, right? You can start playing games. Play Minecraft. Minecraft is nice. One of the best games out there. One of the best games ever. Okay. Make sense. Should we have to take modulo? My bad. Shit, my bad. We have to take modulo. Here, whenever we this thing modulo and here with modulo and come value will never can actually become big because we are adding indices which can be very big. Modulusing. Do you have to do something else? Yeah, nope, good enough. We don't have to make this long. That is nice. We don't have to make this long. That is also nice. 10 power 5 into 10 power 5, 10 power. Yeah, this is already long, so that is nice. Handleable. Out of bounds error, I would suppose. Let's see. Shit. If this is like stuck like the other day, then that would be crazy. And what was the error before? Huh? Error was expected this, found this, which is 3, 3, and 3. Very big. This is 3, 3, and 3, which is smaller. So yeah, I expect found a bigger value. Now it is better after taking modulus. Makes sense. This was a nice question. This was a nice question. I have to work on segment questions where the person, code forces is asking about segments and things like 2 pointers and sliding windows, which we can practice on not lead code but neat code. roadmap. I just have not done this sliding window part, which would be nice. So I'll do that. And we also have binary search, linked list, yeah. Then we can go on to trees. Yeah, this is a nice thing. Sliding windows, we have these questions about sliding windows for practice. That is nice. Shit, bro's back. Mm. Ah, you are not AY Eclipse. It's in the name. I mean, Minecraft is unplayable for me. Minecraft is a very, like, you have to be patient. It is also unplayable for me. I like to watch Minecraft. Yes, watching Minecraft is much easier than playing Minecraft. Yeah. Watching is much easier. And yeah, the tags. To guess the tags, I guess they are going to be. This was actually a pretty cool question. Implementation. We had to be aware of implementation, cumulative sum, prefixes, and yes, I would not have been able to do this without some help. Yes, a little help here. And okay, we use prefixes here, cumulative sum, and for a given cumulative sum, for we were able to figure out how many cumulative sums. Like, wait, if we were to generalize, what we did was when our cumulative sum was equal to some value x, we said that this current index I can be paired up with all of the times that we have seen this exact x cumulative sum earlier. Right. Why? Because the number of zeros had to be equal to the number of ones in this whole range from I to from the previous times that we had seen x's and the current index I. Right. And if we wanted, let's say that that one should be equal to the count of one should be equal to twice the count of zeros, twice the count of zeros, then it will be a bit different, but something similar. We could have done something similar. Yeah, to generalize the whole thing. Let's see. The tags combinatorics. Shit. Yes, we did do combinatorics here. Number of possible choices on the left, on the right, multiply, and we have the answer. Data structures, yes. Implementation maths. Let's see. And tutorial now. There is also video tutorial, all of them in English. Should cry. Cry, the nice person from New York. E. And this was revision 3. And question number E. That is nice. How can we efficiently check if a range contains the same amount of zeros and ones? Let's create an array A where AI equals -1 if SI equals 0 and equals 1 if SI equals 1. Okay. Instead of checking, you are making a different array altogether. Okay. Let's denote P as the prefix sum of A. We want to we want the contribution of -1. We want the contribution of -1 by the zeros to cancel out with the ones. So if for some values r l minus equals 0, then in the range L to R, both included on the emphasis, both included, contains equal amounts of zeros and ones. We can rephrase the problem as the following. For each range L and R, count the number of pairs Fy, count the number of pairs such that their prefixes is same. Yes, okay. Let's fix. Okay, let's fix Px -1 and keep track of potential y such that y is greater than the current index and Px -1 equals Py. so that we can choose it from the prefix. Makes sense. How many subarrays will cover P, X, Y? Well, we have X plus 1 options as L and N minus Y plus 1 options as right. That is combinatorics. So we can just multiply the two possible options. We just need to calculate this expression for all potential y's. Let's denote the possible y's as this. We are asked to find the sum x plus 1 into this plus this. We have taken x plus 1 common. Here we have x plus 1 common. And yep, 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 yep. Yep, only this part, this middle part, y is the only thing that is changing. We can take it sum. Since the second part of the expression is just the sum of all this, we can pre-calculate that. That is cool. That is cool. That does make sense. Why I? Let's see the code. Wait, what is this? Shit. That is a lot of boilerplate, I would say. Friend. Shit, why do they have a structure with friend? That is just too much boilerplate code. A little different. Yeah, that is much better. S, okay, taken S and N equals S dot size. Okay, prefix from 1 to N. Okay, Si equals 1, then 1, otherwise Pi, add minus 1 or subtract minus 1, right? And map long CNT. Okay, answer equals 0 and I equals 0. I will go till equal to 10. Okay, answer equals answer plus n minus I plus 1, the number of choices onto the right, multiplied by the number of choices onto the left. And we are also updating CNT by I plus 1 CNT pi. Shit, this is almost exactly what we have written. That is nice. That is nice. This was a good question. This was a good question. This was actually a good question. Review later at some point and watch later. And now a few more questions. Maybe one more question. Let's see. Darius reverse the reverse. Katrina ordered. Let's go permutation. Or maybe let's do one more segmentation question. Some song segments. Let's do segmentation. Adrenaline rush is also a question. That is nice. And there is also this count that 10,000 people have been able to solve this segmentation some question. But this one, adrenaline rush, only 3,000 have been able to solve it. Let's do this. The harder one. Yeah, good. Wait, because we can submit in C++, that is nice. But this was ICPC 2024-25 shit. North Eurasia Finals unrated online. Oh, shit. Okay, let's do this. Cool. Alice's friend is a big fan of adrenaline rush racing competition and always strives to attend every race. However, this time Alice is the one watching the race. To ensure her friend does not miss any important details, Alice decides to take notes on everything that happens on the track. The first thing that Alice notices before racing begins is the number of cars, all cars lined up in front of the start line in a specific order. The car closest to the line is number one. The second is second, and so on. The last car is N. How convenient, Alice thought. The race begins with the countdown 3, 2, 1, go. Alice observes that the cars start in their original order. However, as the race progresses, their order changes. She records whenever one car overtakes another, essentially swapping places with it on the track. During the race, Alice notices something curious. No car overtakes another more than once. In other words, for any two cars, X and Y, there are at most two overtakes between them during the race. X overtakes Y and or Y overtakes X. No car overtakes more than. Okay. Okay. At the end of the race, Alice carefully writes down the final order of cars, right? Represents the winner of the race. And so yes, no, is this a yes, no? Okay. Alice's friend, however, is only interested in the final ranking and discards all of Alice's notes except for the final ordering. As Alice is quite curious, she wonders what is the longest possible sequence of overtakes she could have observed during the race. Your task is to help Alice longest possible sequences of over. No car overtakes more than once. In other words, for any two cars X and Y, there are at most two overtakes between them. X overtakes Y and or Y overtakes X. Okay. And this is the final order. Final order. Initially they were line 1, 2, 3, 4, and now they are 2, 3, 1. Initially they were 1, 2, 3. And this is the first one, this is the second one, this is the third one. Okay, and we can write them as 2, 3, 1. Initially they were 1, 2, 3. Since 2, okay, since 2 is on the front, 2 did take over 1. So that did happen once, right? That did happen once. But before that, we have 2 and 3 side by side. So 2 could have taken over 3 and then back. So 2 could have taken over 3, or 3 could have taken over 2. That's right. 3 overtook 2. Then we had 1, 3, 2. Then 2 overtook 3. Then we came back to the initial position 1, 2, and sit. Sit. No, no, no. After this, 2 didn't take over 3 again. After this, taking over when we were at this position, 3 overtook 1 because right now they are close to each other. They can overtake, and 3 is on the top at the end. So 3 overtook 1, which made the sequence look like, yes, 3 on top, then 1, then 2. Now 2 comes here. 2 overtakes 1. So 2 overtakes 1, and we have 3, 2, 1, and then 2 overtakes 3. We have 2 overtakes 3. That is nice. 3 overtook 2, 3 overtook 1, 2 overtook 1, 2 overtook 3. That is nice. And 4. Is that that? Yeah, that is the actual answer. Looks good. Right. Okay, looks really good. I think we can think about this in reverse order also. At the end, we have 3, 2, 1. This condition could have, let's say, from this, we are trying to go into the initial position swap by swapping. And we are doing the minimum number of swaps, bubble sort. Bubble sort. We are going to use bubble sort. 2, 3, 1. Shit, yes, we are literally doing bubble sort, and the answer is going to be whenever we shit, but bubble sort time complexity would be n square. We can afford n square. Let's do bubble sort. Swap these two. Swap these two. You'd have 2, 1, 3, and yeah, 2 overtakes 1. Yeah, 2 overtakes 1. Makes sense. 2 overtakes 1. Okay, here 1 will come here. So, but since we are going back in time, this means 3 was here and 3 overtook 1. So we will say 3, 1. And then, right, we are at the end and our bubble sort ends. Then we will see compare 2 with 1 and we will swap 1, 2, and 3. But not just. Shit, this is different from bubble sort because we can sort. We don't want the minimum number of inversions. We want to do some extra work also if we could. Yes. Okay. Then after this, here 2 overtook 1. So we'll write the second number, this, and then the first number 1. And now 1, then we will make one more extra pass and we will see, has this current number overtaken with the next number, done overtake with the next number. Yes, that is the only thing that we want. But we could also do these things in the middle. Let's say we are doing them here. Yeah. Yeah. Here, 1 has overtaken with 2, so we cannot do anything. But 2 and 3 have not crossed paths ever, right? They were in different things. So we will say 2, 3, and 3, 2. 2, 3, and 3, 2, which means 3 overtook, and then 2 overtook again, and we were back to the same thing. 2, 3, 3, 2. Yeah, yeah, same. So to add this final step of extra taking over, we have to know, has this current number shit, but not just that. This is crazy. Okay, not just that. Yeah, we can do this right now here. We know that these two are already in the correct order. So we can do 2 swaps right now, and that would be nice. That would be nice. That would actually be nice. And then we go to the next thing and we see, oh shit, they are in the opposite order. We do 1 swap, which makes so much sense. If our final order was like this, we can turn this thing around completely. Yes, we can turn this thing around completely. We can say, uh, we can swap these two and get 1, 2, 4, 3. Then we can swap these two and get 1, 4, 2, 3. Then we can swap these two and get 4, 1, 2, 3. And yeah, 4 has been done. 4 has been, yeah, done for like with every number once. So yeah, we can only do it once more. Yep. And then in this range, we will do the same thing. 4, 1, 3, 2, 4, 3, 1, 2, and 4, 3, 2, 1. Now, every other number has been swapped with every other number at least once. Now we will do the whole thing in reverse. So 3, 4, 2, 1, 3, 2, 1, 4, 3, ah, shit, 3, 4, 2, 1, 4 here, 1 here, and 3, 1, 4. And then, yeah, 2, 3, 1, 4, and then, okay, so where are we going with this? What can we do with this? Hello, how is everything going back? Shit, okay, stop saying you are a noob. Only I can say that. Wow. Try doing this question. Yeah, this is a nice question. This is a nice question. And we did the earlier question. Eric, thank you for your help. And yeah, the earlier question was pretty cool. This was the code that I wrote for that. Where yeah, earlier I was taking pairs, but then I stopped taking pairs and for a given cumulative sum, this would be the number of possibilities on the right, and this is the sum of all the possibilities on the left that this one can go with. That makes actually a lot of sense, right? And that is cool. That is cool. Yep. So let's go. We have similar thoughts. And for this one, we are going to apply something sort of bubble sort, not just bubble sort. We will see for, yeah, we can, whatever our initial input, whatever it is, 2, 3, 1. I think we can divide this into sorted and unsorted. And we will take, yeah, sorted or unsorted. Yeah, we can divide this into sorted and unsorted. And if a thing is sorted, then we will see, starting from this index, how far along is it sorted, right? And in that thing, we can do bubble sort like in this manner. We can make this 3, 2, 1, and then 2, 3 back if the current thing is sorted. But if the current thing is not sorted, we will have to do bubble sort. 2 and shit, not just bubble sort within that segment. Shit. I think whenever we make one move of bubble sort, like if we have 3, 4, 1, 2, 5, and let's say we are currently uh, oh, okay, this is not a good example. Let's say we have 1 here and 7, 6, 2, 3, 4, 5, and we are currently here. Right. No. 2, 3, 6, 7, 1, 4, 5, right? And we are currently here. No, shit. We are currently here. This one is not sorted according to this, right? and we'll have to do our bubble sort thing here, and we'll say we swap this 7, 4, 5. We have swapped these two things, and is this number at its original place? No. And yes, we are going back in time. We are going back in time in this. Is this number at its original place? No, that does not even matter. Should, okay, amazing. Okay, amazing. Our current pointer I is pointing to something that is sorted. Yeah, that is sorted. Our current pointer is pointing to something that is sorted. So this element can has not. It is sorted. Yes. Wait. No, no, no. It is not. No, the current left thing is not sorted. What we want to do is quick sort. No, not quick sort. Insertion sort. Yes, we need insertion sort here. Uh, yes, since we know that this number just came out from the right side or whatever it is, then we will take this number to the start by swapping it with every other number, and then we will keep swapping it back till it is at its right place. So in this case, yes, let's go. Initially we had 2, 3, 6, 7, 1, 4, 5. Initially our pointer would be here and there is nothing on the left. We are already at the left, so amazing. Then our pointer was here and this is sorted now. We'll take this to the left and we'll say 3, 2, dot, dot, whatever is on the right. And then we'll keep moving this towards right till the number on the right is smaller than this current number. So this would become 2, 3. Yeah. And then we'll start pointing at 6. And now this is sorted. The next iteration would be this. Our pointer would be here. 6 will go again towards the left. So 6, 2, 3. Pointer is here. Then we will keep moving this right towards till the right element is smaller. So at the end, we will still come back here. The next element was 7. Cool, we'll do the same thing. 7 will come back here and 1. And this would work because we are using insertion sort, but we are doing extra steps and maximum number of extra steps which we can do. Okay, which problem do you solving? This one right here. And great markup, by the way. Shit, this is good. This is good. We can solve this. Cool. And we do not have test cases. That is nice. We just have one massive big test case. A and cool for in reference X in A Vim. Right after this in I equals 0, I is sorted. Everything is sorted. Okay. For and shit, since we are going back in time, we need to store everything. We are going back in time, literally back to future. Okay. Vector of pairs. Yeah. Response size we don't know, but it is going to have this. Makes sense. We don't even need this. Yeah. For int I, it starts at 0, I less than n, I plus plus. And the invariance is everything beginning from 0 to I inclusive, inclusive is sorted. Okay, makes sense. Okay, in J equals I while there is something on the left. First of all, we will take the current element to as left as we can. So while J minus 1 is greater than or equal to 0, yes, just that is the only requirement. So here we will swap and we will add to our response. Response dot push back a pair. Who is overtaking who or who overtook who? Since this is going back in time, the two participants are a J and a J minus 1. So which one comes first? AJ will take AJ minus 1's place. 3 will come here, 2 will come here, and when we are reversing time, it would seem like 2 overtook 3, which is AJ minus 1, comma AJ, and J minus 1. Or we, yeah, that is nice. A while loop is nice. A while loop is nice. And shit, we also have to do, yes, everything on the left is sorted. That is nice. Swap AJ minus 1 and AJ. Now, J equals 0. Right, makes sense. J equals 0. Hello, which rating problem is this? And what is our CF rating on CF? It is like 1400 right now, just. And yeah, this is 1600 rated question, which is nice. And hello, love to see you this consistent. It really inspires me. Thank you for this. I mean, yes, really thank you. I will keep coming every day. Yeah, actually, thank you. And okay, J starts from 1. Now this element will go forward while J plus 1 is smaller than or equal to I. We can go there, and not just that, I has to be smaller. AI has to be smaller than AJ, not EI. Shit. Not EI. AJ plus 1. The next number has to be smaller so that it is in its like right order. Makes sense. Okay. If this is okay, and here the participants again are AJ and AJ minus 1. We're swapping these two positions and we'll say red dot push back AJ minus 1 and AJ. Is the order correct? So shit, okay, back to the drawing board. We had these to change. So this came here. And like this is at time equals, let's say, t equals 2, and this was at t equals 1. So when we go from this time to this time, it would look like 2 overtook 3. Makes sense. And now we are bringing 3 back onto the right. So this would look like this when time equals was equal to 0, which it would look like this number overtook this. Okay, so yeah, the order is correct. and j plus plus. And now we can just output for aut- auto x comma y. We have to output in the reverse order. The last step would be the first. So for int I equals this dot size minus 1, I greater than equal to 0, I minus minus, let's go, and auto x comma y equals this I makes sense, and see out x space y and a simple new line. Double definition out of bounds somehow. Take an n, fill up a, Phillips, fill up a, and this thing. I think let's say this. Okay. And yeah, cool. Shit. We have to initialize this empty thing. Makes sense. And I, okay, this is nice. This is nice. This is nice. What is wrong? While there is a thing on the left. Okay, that is nice. And this is also nice. J plus plus. Yes, J plus plus makes that is correct. See out rest dot size. Let's go. That is actually correct. 3, 1, and absolutely amazing. Absolutely amazing. Shit. That is shit. Actually, bit cool. Insertion, sort. Bro, please solve all problems. Who is possible for you on contest, on code forces and code shifts? Shit. I have a different belief system, I would say. Uh, like whenever I want to practice, I do not have to think which thing to open, whether should I go to code forces or lead code or whatever. I just know I'm doing code forces, so just go to code forces. And if I'm getting good at code forces, I will be able to solve questions on any other platform. It would like take maybe 2 to 3 days to get to know the semantics of the other platforms. I cannot make logic for those problems. So after contest, I'm trying to solve those questions. So will you help me? Wait, maybe I misread what you meant. Misunderstood. Should come interpretation error. Solve all the problems. Who is possible for you on contests on these? Okay, yeah. I mean, yeah, you can send on the Discord and we can see. And maybe not get wrong answer on test number 1. 3, 1. Then that makes so much sense. How can 3 and 1 take, how can 3 and 1 take over? Huh? Like, yes, shit. Yes. You can send the questions on Discord. That would be very nice. Like we can work around something there. This is not sorted at the end. This is not sorted. Okay. Seems like we cannot even do some little shit. And the next element is smaller. Go there. Go there. Shit, we didn't come back. That is bad. G was equal to 0. Okay. What was the state after this? Let's see. Okay. This was equal to, yeah, same. Cool. Okay. We didn't do anything. We were supposed to take this 3 onto the right. We didn't do that. So I was equal to 1. Okay. I was equal to, my bad. Much better. Let's go. A little, there was a little mistake. Now it is fixed. And yes, the mistake was that we were not literally swapping the elements and we were just supposing. Okay, at least we passed test 1 and 3, 2, 2, 3. Okay, shit. There are a lot of test cases from 40 to 50, 52. It's like 26 into 2. Accepted. Cool. 34 minutes around. Okay, that is nice. That was a nice question. That was a nice question. Let's rewrite the question and I will go to the washroom and I will be right back in a minute. I have to pee and then we will. Good one. Yeah, that was a good question. This one. We had to like look at insertion sort through a new lens, change your perspective or something. Yeah, I'll be right back. Just 1 minute. Yep. I am totally done. Congratulations. So you solved your problem. Thank you. And let's resolve this whole thing. Okay. We first of all do not have multiple test cases. Yep. And n, take in n, vector in A, size would be n, for in reference x in A, C in X. Right, cool. And yes, a vector of pairs of integers, we will call this the response, size unknown. And now the fun begins. For in I equals 0, I less than n, I plus plus, we'll start iterating from the first index, and our hypothesis, or we could say our invariance, that is the thing which is not changing at the end of each loop, and which is also true before the loop begins, and is not changing throughout a single iteration, and also is true at the end of the loop when we exit from the loop, is the range from 0 to I, where 0 and I both are included, is sorted. And we can begin from I equals 0, because in that thing we only have one element, and which is like, of course, sorted. And what we are doing is this: for any element, let's say we are at index I, right? And we are saying this whole thing is sorted. It is in increasing order. And we'll take the first element here. Or when we get to a index, we are saying I minus 1 is sorted. This whole thing on to the left is sorted. And this one, what we will do is we'll keep this and keep moving this to the left, to the left, to the left. Then this element, AI element, will come to the first location. AI would be here, and this whole thing, which was originally here, has been shifted to the right by one element. And now we will bring this back, and we will keep moving this towards right till the element onto the right, a whatever ax, is smaller than ai, so that ai in this given array comes to its right place to make this whole thing from 0 to I sorted. And that makes sense, right? Right. So first of all, we will take this thing back. In j equals I, and while there is something on to the left, that is while j is non-zero, while j is non-zero, and nothing else. While j is non-zero, we will say response push back the last one with the current one, which would be aj minus 1 comma aj. Make sense? And actually swap this thing, swap aj minus 1 and aj. Cool. Now we have taken shit j minus minus. Now we have taken this ith element starting from here towards the left. Yeah, like the first position. We will say j equals 1, 0, and we will keep moving towards right while j plus 1 is smaller than or equal to I. We will not go outside our range that we are considering right now. And also, if the element on the right is within the range, and also aj plus 1 is smaller than aj, and we are not looking for equal to, because no two elements are equal to each other, right? If this is true, then we will say not swap, but first of all we will add to the response push back a j and aj plus 1. Cool. And swap a j and aj plus 1 and j plus plus. And cool. Since we began considering our whole thing from the final configuration of A, this thing is like we have to output the answers in the opposite order. I equals not 0, but rest dot size minus 1, I greater than equal to 0, I minus minus. But before outputting the answer, we have to output the size of the answer, rest dot size with a new line. And here we'll say auto x comma y to like, and destructure is the word, unbind or destructure destruct res I, and then we will say x swap places with y. Yeah, cool. And let's submit just in case. That would be nice. The if this works, if this doesn't work, that would be crazy. Okay, it does seem to be working. Should memory? We have used a lot of memory. Can we reduce the amount of memory that we are using? No, we cannot. We cannot reduce the amount of memory that we are using. Maybe we can when we do know this, let's say not X, something that we haven't used throughout. We cannot use less memory, but what we can do is speed up time or yeah, fix time. We can say rest dot resize. What is the maximum thing that we can have? N can be maximum this much, and here we say n into n. Yeah, n into n. Maybe this will make the whole thing a little bit faster or slow. Okay, how to give a okay. What I'm trying to do here is increase the size of our vector to the maximum things that we can store, to the maximum number of pairs which we might store while calculating, so that whenever we are doing a pushback, we are not getting more storage. But I thought the resize function would do, but it is not working. Okay. How to increase capacity of brain? Capacity of a vector C++. Capacity. Place. Reserve, not resize. Cool. Let's also read the definition for emplace, but also let's benchmark on code forces. Let's see. Since we are not asking for memory again and again, maybe this might not help in the time. Okay, shit. Memory is fine. Memory is much better. That is nice. Memory is like half of the original one. That is nice. I was expecting better time, but not better memory. I think memory is reduced because whenever like we hit the end of an array, whenever we are doing this pushback and we don't have enough capacity in the array, we get like a new array twice the size, and we shift all of these elements here onto this new array and add that new element that we wanted to add here. I thought that this thing would like help in time because we won't have to copy paste all of these things again and again. But this is not helping in time, but actually in memory, because I think when we are getting this new memory, we are not freeing the last one. But here, since we are already asking for a lot of memory, We don't have any lying around memory which we are not using, like that. That I think makes sense. There also another function emplace back, push back. Reserve makes sense. My vector dot push back. What does emplace do? Push back or emplace back? And emplace is, we can also use emplace back for adding a new element, but the arguments that you are going to pass. Yeah, sure. Sure. Yes, this makes sense. This is okay. Here and place back and fit and shit. I think this will improve in time, because what emplace back does is whatever the type of elements is that we are storing in our vector. Like since this is a pair to be initialized takes in two numbers. And earlier, when using pushback, we were creating a pair and then we were passing that pair to be added, to be added uh, onto our response vector. But since we were passing a pair, a copy of that pair which we passed was being sent to res to be added there. And that was like, yeah, that was bad because we are creating a copy. But here, these arguments themselves will be passed on to the pair constructor to construct a new pair. Let's see the hypothesis is correct or not. And I'm predicting that this will help in time. This will help in time, and also we have already helped ourselves in memory. Let's see. Maybe not. It's okay. It is running. Let's see how this goes. Yep. Check. I mean, this also depends on how things are going on right now. Yeah. But yeah, this would be much better. Like this is objectively better than using pushback. And I think we should actually use pushback. Let's ask ChatGPT because we won't be doing any much question. Still taking too much. No, memory is fine. Uh, memory, memory is fine. I think we cannot do better than this. How many test cases do we have? We have in total quite a few test cases. 54. Okay. We have in total 54 test cases. And in each test case, we are taking 10 to the power 6 pairs. And let's just say a pair is just two integers. One integer takes 1 byte, two integers take 2 bytes, or one integer takes 4 bytes, two integers take 8 bytes. So we have 8 into 10 to the power 6 bytes. That would be like 8 MBs, 8 megabytes. This many bytes, and this is 10 power 6 mega. But we are using like lower than that, which is crazy. This is actually crazy. We are not even using the minimum amount of bytes we would be using. 8 megabytes because of C++. Shit, this might be because of C++. Shit, be- a function like vector, like container like vector does not call malloc itself. It is done by C++. That's running C++ code has something called the free space. Not the free space, but the how can I forget? Not free space, but free store. Free store. Yes. So C++ programs or these allocators take things from the free store, which is which has already taken a lot of heap memory for your program to run. And I guess, I suppose, yeah, something related with that. I don't know. I cannot say. Rejected, shit, retracted. Yes, for ChatGPT, the question was, is it true that cats can understand human emotions? Shit. Is it true that using a place back is better than using push back in C++? Since for push back, we have to pass in a pass in the object itself that we want to append, and then a copy of that object is created and added to the a copy of that object is created and added to the vector. Mm, But if we are passing the object as a R value, that is, we are just creating the object for the sake of passing it to push back. We have one extra copy of the object isn't which isn't even needed, and the laptop is going to die. Yeah, much better. C++, try coding. Shit, D++ is a language. Actually is a language. Misnomer for D, programming language is a learn. Shit, right there. D. There's also B, which we can learn. Module, hello, import. Shit, we are using import. If you're like me and spend way too much time on the internet, odds are you have heard about D. The D programming language is a modern general purpose multi-paradigm language with support for everything from low-level features to expressive high-level abstractions, expressive zero-cost abstractions in Rust. D is actively developed by a large group shit of smart people, super smart people. Shit, now this seems like a troll and is spearheaded by Walter Bright and Andrei Alexandrov. So, okay, with all that out of the way, let's look at some examples. Shit, this person and shit, why is this in light mode? He has done the programming language and a compiler, Zortec compiler for C++. That is crazy. And Empire computer game. It was nice early life career. Yep, like yes, that is not stalking. This is like gathering resources. Romanian American programmer. I thought this was a Russian name, but similar. Andre. Andre. Not Andre the Giant. Andre. Karpathy is Slovak. Slovenia, Slovakia, and Canadian. Okay, I thought he was American. But back to this thing. Lol, I made that up. Shit, shit. Inherent law knowledge, I suppose. Now I want A plus plus. B is there. B is there, and yeah, B is there. Excel. We can learn B. Learn X in 1 minute. B. Shit, B is not here. B was B was written by Ken Thompson, Dennis Ritchie, yeah, developed by Ken Thompson and Dennis Ritchie, Bell Labs, 1969 was C made. So C was made in like 1970s, 1972, 72, the same year that Godfather came out. So yeah, historic year. Okay, object which isn't even needed. But if we were to use and place back, we would we would give the exact arguments to the place back method that we would have given to the object constructor, and thus only one copy is made and added at the back of the vector. Cool. Okay. You are very close to the truth. Sit. Push back with an existing object here. Push back, we created the object and then we added f is the a and l value. So push back will copy it. We have copy constructor. You get one extra copy. To avoid this, we can do pushback move. Okay, we can do move. Now there is no copy, so move is better. Still not free, but cheap. Then with a temporary r value, yes, like this. Yes, the temporary r value is created outside the vector. Then it is moved into the vector using the move constructor. Okay, shit. If you are sending a r value, then it is moved. Okay, my bad. Makes sense. Companies, we like you need to know all the languages from A to Z. Yes. Let's make one plus plus. Shit. One plus plus, that would just be two all the way till infinity. Bro has high hopes. Technically, we can go up to infinity if we change like changes like Apple. For real, for real. Technically, we can go up to infinity if we change, if we made changes like Apple. Yes, we can go. I think I don't understand that part. Okay. So the thing is, when we are passing in a R value, that is an object or a value which does not have a variable which is pointing to that. In that case, we do not create a copy. The R value itself goes at the back of the vector using a move constructor. So that makes sense. It's constructed directly into the vector's memory. No temporary object, no copy, no move. Okay. Temporary created. Yep. No. Yeah, makes sense. Yeah, this is cool. Makes sense. And we have done quite a few questions today. We did well this one, but this one was, yeah, I also did this a few months ago, so we cannot act 1 month ago in October. Yeah, we cannot count this. So we did this one, Doremi, then decode. Decode was, what was decode? Doremi was nice. Yeah, decode. Shit, yes. Decode was nice. Decode was actually nice. We had to make Eric used a term, like a specific term for the decode one. Backward pass. Okay, backward pass. We used something called backward pass for this one. That is nice. Bro doesn't know iPhone jokes. Shit. No, my bad. Yes, we used backward pass and decode Doremi's IQ was also nice. Shit, we did backwards pass on Doremi's IQ, and for decode, yeah, this is decode. Shit, this was the one. This was the one. This was the one on which I got like messed up, and Eric helped a lot. Yeah, on decode. Yeah, this was a nice question. This was a nice question. Using cumulative sum and maps. Yeah, this was a nice question. And then the one that we did just now. Adrenaline rush. Using insertion sort. Nice. I will revise them later. And for today, that would be it. I think he meant like Apple released the iPhone early. They will same just change the cameras and better battery. If you made Apple is a battery company now. Apple has better battery. A plus plus consistent for a loop we can make that for 1 ms millisecond faster for B plus plus. If you can do that using assembly, GPU acceleration. And yeah, that would be the end of today's stream. And thank you for being here.